division of fractions is actually very much like multiplication of fractions. There's just one thing we've got to do to change the operation on this thing. So I technically never, ever divide fractions. I only multiply them. We just have to remember what a reciprocal is. So a reciprocal is where we're going to take any fraction. Now it has to be in either improper fraction or proper fraction form. It can't be a mixed number. So we may have something like, I think in the book I've seen this B over C. Maybe it's on a calculator. If I took a reciprocal of this fraction, it'll still be a fraction, but we're just going to flip the 2 here. A lot of people like to use the 2 fingers and do this kind of thing. That's what we're going to do. Now the C is in the numerator and the B is in the denominator. See? Some people, and this is what I do, I like to show it like this. We're just switching those 2. Now reciprocation is what will change the operation from division to multiplication, but it's which number that we have to change that kind of confuses people. The good thing is that it's always the same number, unless for some reason they give us a lot of numbers. So, for example, on this one, again, I don't divide, I'll just multiply this thing. It's the second number. Now, if I remember right, we call that the divisor, and the first number is the dividend. So I may use that vocabulary a little bit around here. I usually just say the second number here. So if I change this to multiplication, I need to flip this second fraction. So it now becomes 2 over 1. That first fraction is going to stay exactly the same. See, now we've changed this into multiplication, which, well, by yesterday, it seemed like you guys felt pretty comfortable with that stuff. So I'm just going to multiply the numerators and denominators. 3 times 2 is 6. 5 times 1 is 5. And I can keep that as an improper fraction. So on this one, we got the 2 negatives, which will change into a positive. It's the opposite of negative. So that's good because we don't have to worry about those now. Now again, we keep this first fraction the same, but I'm going to change the division to multiplication, and then I'm going to flip this fraction or reciprocate it, which would make it 16/3. Now some of you would cross-simplify the 8 and 16, but let's say we didn't notice that because we don't have to. So 7 times 16, 71, 12, over 8 times 3, which is 24. Now these are both even numbers, so we should be able to at least divide by 2. And that would give us 56 over 12. And again, we can divide these by 2. And that gives us 28 over 6. And we can divide by 2 again, which would be 14 over 3. And that's as far as we can simplify that. This one's really not too bad. I'll use cross simplification to simplify the process here. So that first number is going to stay the same, negative 18. Again, we'll change this division to multiplication, but when we do, we have to reciprocate this second number. So 3 over 2. Now this may look a little confusing because negative 18 is not a fraction, so we can make it a fraction as 18 over 1. Now we can multiply the numerators and denominators. I'm sorry, I said I would cross simplify, right? So 18 and 2 simplify to 9 and 1. So negative 9 times 3 is negative 27. And then 1 times 1 is 1. So really, this is just negative 27. This one has that a squared, which is really the only difference between the problems that we've just done and this one. But the a squared really isn't going to change anything. Let's look at this. 15 a squared over 28. Now we'll change this to multiplication, but we'll reciprocate the 7/10 to 10/7. I don't see anything that really stands out to me as simplifying really easy, so I'll just multiply these. 15a squared times 10, and yeah, we got that negative. That would be 150a squared. And we have to remember to include that a squared in this new fraction. 28 times 7, 196. And the only thing that I can tell here that is simplifiable is that the 150 and the 196 are even, so we should be able to divide these by 2. So that gives us a negative 75 a squared over 98. And these two numbers, both of them are not divisible by 5. They're not even. One is even, but the other is not. And 7 plus 5 is 12. 9 plus 8 is 17. So they're not divisible by 3 together. So it looks like we've simplified that all the way. So this one is good because it does give us some stuff to simplify in terms of the letters there. So I'm going to expand p squared to just be p times p. And now I can get rid of that squared part right there. What this does is it allows us to cross simplify the p's out of this thing. So this p can cancel out this one. And this q, no, I'm sorry, I can't do that. What the heck? That's only for multiplication, dang it. So let's change it to multiplication. 15p times p over 10q. Let's change it to multiplication. And we'll reciprocate this fraction. 3p over 5q. So that was a little tricky. I just kind of ran into that one blindly. So be careful. Well, we can cross simplify these. The 5 and the 15. So that would become a 3 and a 1. And none of the letters are going to cancel out in this case. So I got 3 times 3, which is 9. And then I've got these two p's and this p right here, which would be p to the power of 3, because all of this is multiplication. And then I've got 10 times 1, which is 10. And then this q multiplied by this q would be q squared. All right, the tank for a car holds 13 gallons, I guess, of gas. The gas gauge shows the tank is 1/8 full. How much gas is still in the tank? Well, if we have a 13-gallon tank, but only 1/8 of it is full, we can multiply this by 1/8. So here's the problem here. Is at the beginning it says, does it require multiplication or division? It kind of requires both, because right here I'm multiplying it by 1, and that's divided by 8. But in reality, we could just take 13 and divide it by 8 as well. So how much gas is still in the tank? I assume they may want a decimal answer on this. And, well, we can make that 13 over 1. And so 13 times 1 is 13. 1 times 8 is 8. I'm okay leaving it like this. 13/8 gallons. I mean, it's almost 1.5. What is that? 1 point.
1 5/8.
Oh yeah, the mixed number would be fine. This one, yeah, 5/8, right? Gallons. Yeah, thank you. Well, what about number 9? The recipe calls for 1/2 cups flour, 3/4 cup of sugar and 2 eggs. How much of each ingredient do you need if you half that recipe? So for the flour, okay. The flour we're going to need 1/2 cup for the original recipe, but if we're going to cut that in half, it really means we're going to divide this by 2. Now again, we'll look at this as 2/1, so that when we change this, I got the 1/2, but I'm going to change this to multiplication and reciprocate the fraction. So that'd be 1/2, which should give us 1 times 1 is 1, and 2 times 2 is 4. Of course, some of you knew that half of a half is 1/4, too. So, but that supports it with the work there. If there are 29,600 students at SLIC and 1/3 of the students take math, how many students take math at SLIC? All right, well, we got this 29,600. And this one's kind of like number 8, 1/3 of those. So we're going to multiply this by 1/3. And, well, it doesn't appear that that will be simplifiable, so I'll just do this on my calculator to find that decimal. Well, let's look at the multiplication first. So 29,600 times the 1, 29,600, and then we can make that over 1. 1 times 3 is 3. So, again on my calculator, 29,600. Now that's divided by 3. Yeah, that gives us a pretty ugly decimal. 9,866. Now it gave us a decimal, which repeats, but if you rounded this, I would be okay with that as well. Just we have to remember to label that. That's, I apologize. Maybe it's this morning stuff that's killing me. But we got to go back to number 9 and cut everything else in half. So let's look at the sugar. The sugar was 3/4 of a cup. And again, we'll divide this by 2. We'll make that 2/1. And we'll reciprocate the 2/1 to make that multiplication. So 3/4. Now this is multiplied by 1/2. And the 3 times the 1 is the 3. And 4 times 2 is 8. So 3/8 of a cup. Should label these of a cup of sugar. The 2 eggs, that one's the easiest one for the eggs. It wants 2 eggs. We're going to cut that in half. And no need for changing that into multiplication. 2 divided by 2 is 1. So 1 egg. Next one, it is estimated that each guest at a party will eat 1/4 pound of meat. How many guests can be served with 4 pounds of meat? All right. Well, this is 4 people. Now each of them is going to be eating 1/4 pound of meat, so we're going to divide this up into fourths. All right. I'm sorry, that's 4 pounds of meat divided into 1/4 pounds. So we'll make that 4/1 if it really helps us. But we just need to change the division to multiplication. So we'll keep the 4. We'll change the operation of multiplication and reciprocate the 1/4. So that becomes 4/1. Again, that's not going to make a big difference. 4 times 4 is 16. 1 times 1 is 1. So this just ends up being 16 guests. So on this one, again, this first number here is going to stay the same. Negative 12b over 2b. And in fact, we could have canceled out those b's right off the bat. But let's change this division into multiplication. And again, when we do that, we'll have to reciprocate this fraction. So now I got a negative 6 a squared over 3. Now I do have these two negatives, so we'll just change those to positives, because they will cancel each other out. And this gives us, I'm going to cancel out those b's actually, so that, we can see that, hopefully those cancel out right away. 12 times 6 is 72, then we got the a squared, and then 2 times 3 is 6. Well, 72 divided by 6 is 12. And then we're just left with that a squared.